So, we've all gotten used to AI that can answer our questions or maybe draft an email for us, right? But what if an AI could do more, a lot more? What if it could take a simple goal like plan my trip to Tokyo and then actually go and book the flights, reserve the hotel, and build a custom itinerary all by itself? Well, that's the core idea behind Agentic AI, and believe me, it's the next giant leap for artificial intelligence. So, here's what we're going to cover. First, we'll get a handle on what an autonomous AI agent really is. Then, we'll look at where they're already popping up in the real world. After that, we'll get into the important stuff. What happens when these things go wrong? And finally, we'll explore how we can build them smarter and put the right guardrails in place for this whole new era of AI. All right, let's kick things off with the absolute basics. What does it actually mean for an AI to be agentic? Well, it's a huge shift in thinking. We're moving away from an AI that just follows a checklist to one that can actually figure out its own path. At its heart, an agentic AI is a system where you give it a destination, not a detailed map. You give it a goal, and from there, it's on its own. It has to observe what's going on, analyze all the data, deal with confusing or incomplete information, and then string together a whole series of actions to, get the job done. A really great way to get your head around this is to think about the difference between a smart intern and a calculator. A calculator is perfect, right? It does exactly what you tell it. 2 + 2 is always 4. But it can't think for itself. An agent, on the other hand, that's like that amazing intern you can just say, hey, go research our top 3 competitors and put together a summary of their marketing strategies. That intern figures out the how. That's the game-changing difference. And this really comes into focus when you compare agentic AI to the older kind of automation, like robotic process automation, or RPA. RPA is super rigid. It's all about if-then rules. If a button on a website moves a few pixels, the whole thing just breaks. And it pretty much only works with perfectly clean, structured data. Agentic AI is the total opposite. It's goal-oriented, it's dynamic, it can actually adapt when things change, and it has no problem with messy, unstructured data, like the stuff you'd find in an email or a PDF. Okay, so I know this might all be sounding a little bit like science fiction, but it's really not. It's already happening. So let's take a look at where these agents are already working out there in the wild, tackling some seriously complex, real-world problems. Okay, take urban planning. In some cities, agentic AI systems are basically becoming the ultimate traffic controllers. They're pulling in data from GPS, from sensors in the road, even from weather reports to dynamically change traffic light patterns on the fly. They can clear up bottlenecks before they even form, and even prioritize a clear path for an ambulance in real time. Then you've got factories and farms. These agents are total game changers for efficiency. They analyze all the data coming off of heavy machinery to predict failures before they actually happen, saving a ton of money and downtime. And in agriculture, they're using sensor data to autonomously manage just about everything, from when to water the crops to deploying drones and robots for harvesting. And in really high-stakes fields like finance and law, agents are doing things at a speed and scale that, let's be honest, no human ever could. They're analyzing market data and executing trades in milliseconds. They're sifting through mountains of legal documents for case research, freeing up lawyers to actually focus on strategy. It's incredible. But, and this is a really big but, with this much power and autonomy, you're also taking on a significant amount of risk. So the question is, what happens when these super capable agents get it completely and utterly wrong? There was one analysis of agentic AI failures in coding that just puts the danger perfectly. And here's the paradox, right? An agent's greatest strength, its ability to think for itself, is also its greatest weakness. Failures happen when just one tiny little mistake becomes the shaky foundation for a much bigger, totally wrong conclusion. It's like the AI version of a small white lie that spirals into this crazy, unbelievable story. So the main takeaway here is that the biggest failures aren't just simple little bugs. They're deep, fundamental flaws in the agent's own reasoning process. The agent gets stuck in what researchers call a cognitive deadlock. You can think of it like being hopelessly lost but refusing to admit you made a wrong turn 10 miles back. The agent just can't see its own mistake, so it keeps trying the same broken approach over and over again. And these reasoning flaws, they tend to show up in a few very specific ways. For example, there's superficial matching, where the agent just latches onto a key word and completely misses the real problem. Then you have specific case overfitting, where it comes up with a fix that only works for one tiny little example, but not the general issue. And my personal favorite, evasive repair. This is where the agent doesn't actually fix the bug at all. It just wraps the broken code in a command that basically says, hey, try not to crash, okay? It's essentially just ignoring the problem and hoping for the best.
Okay, so understanding how these agents fail is really the first step to making them better. So let's turn to the solutions and look at the frameworks that developers are building to create more reliable, more robust agents. One of the most promising ideas is what's called the expert executor model. It's basically like AI pair programming. You have one agent, the executor, doing the main work, but, and here's the clever part, before it actually does anything, it has to run its plan by a supervisor expert agent. This expert acts kind of like a senior engineer doing a code review. It looks for flawed logic and helps the executor break out of those cognitive deadlocks we were just talking about. And of course, one of the most reliable ways to stop a disaster before it starts is to just put a human in the loop. Agents can be built with these checkpointers that force them to pause at critical moments. They can ask for our input or even require our explicit approval before they take any big, high-stakes action. It gives you the best of both worlds, the speed of AI combined with solid human judgment. But look, building a reliable agent is only half the battle. Their autonomy also cracks open the door to a whole new set of security threats, and it's forcing us to completely rethink what control even means in this new AI world. Security groups like OWASP are now flagging threats that are completely unique to this technology. For instance, you could have an agent with excessive agency. You give it permission to read a file, but it decides on its own to delete it. Or an attacker could use prompt injection to trick the agent into running malicious commands. And because these agents are plugged into our systems, they can be tricked into leaking sensitive data or executing harmful commands if their outputs aren't checked very, very carefully. So to manage all these risks, the key isn't to have a simple on-off switch for autonomy. It's more like a dimmer switch. Frameworks like the Agent Security Scoping Matrix help us do exactly that. At the most restrictive level, prescribed agency, pretty much every single action requires a human to say yes. As you move up the scale to supervised and then full agency, the agent gets more and more freedom, and our role shifts from micromanaging every action to just guiding the overall strategy. And all of this leads us to the ultimate question, the one that's going to define this entire age of agentic AI. We are building systems that have the power to act on their own in the real world. The challenge isn't just making them powerful. It's about ensuring they stay safe, they stay reliable, and most importantly, that they stay fundamentally aligned with our goals. And how we answer that question, well, that's going to determine everything.